Yeah, hello friends. How are you doing? I hope you're all doing well wherever you are. Thank you again for coming. Uh, I'm so happy to again make this video for us. Today I want to continue. We did a video last time and we were talking about finite element analysis. And I was explaining the basics of finite element analysis. The basic principles behind the finite element analysis. Well, today I thought of making a video to explain how it really works in a software, so that I show how we can really, do that analysis in a software, so that we come up with the results which you can use to design. Well, so the software I want to use for this purpose is called protastructure, and yeah, you can see here it's protastructure, and I just want to move quickly and do the analysis. Well, I'm not going to explain the software for today. The main target is to show us how we can do the finite element analysis, and how we can know our results, which you can use to design. So this is what will if you launch the software, this is where it will bring you to. You have two options. You can either open a project which is already existing, or you can just start a new project, right? For this case, I just want to start a new project because I want us to start it from zero so that we can all move together. Well, so just go to new project here, and it will bring you to a window where you can set the name of your project, and you can also choose the code of practice which you want to adopt, right? So for this one, let me just name it maybe finite element methods. That is the name. Let me just name it like that. And then which code of practice you want to adopt. For this case, let us go with BS 8110. Then it will load. It will take us to a window where we now start our design purposes. Just give it a few minutes. Well, so this is it. So let me start from my left here. You have option of axis, you have option of views, you have option of plans. These are all ways where you can manipulate your project. But of interest, what I want to speak of is stories here. Stories. So by default, we only have a single story which the project is set to, right? But you can add as many stories as you want. What you do is just go to building set out here, then the story options here. Just click the drop down arrow, and then insert story, right? So how many stories do you want? Let us just go with 3, maybe for this case, or even 2. Well, let us just use 3 for this case. So if you can see here, it has now moved from 1 story to 3 of them, because we've added some other stories. So this is what is of interest at this point. Then the next thing, before you do any construction works, you need to have your grids. Same to these. Before you start modeling here, we're going to put in grids, which will guide where our beams will be, where our columns will be, for purposes of this analysis. So to do that, just go to modeling here. After modeling, simply go to grids. There are 2 options. You can either generate grids automatically, orthogonal grids automatically, or you can just draw your grids manually. If you want to draw your grids manually, that is how it goes. You can just click where you want your grid to start, where you want your grid to end, like that. But for purposes of this video, I want to generate grids orthogonally. So what I do, I just come to orthogonal axis generator here. Then I tell the software where I want to start. I want to start at that point. Then I just tell the software what is the spacing between my grids. I just want to use uniform spacing between my grids for this case. 3 meters in every side. Let's just adopt 3 meters, and let them be three spaces. Same to this one here. Let's just adopt 3 meters and say OK, and our grids are already in. Very interesting. Yeah, they are all 3 meters apart, right? Well, so after that we want to now put in our columns, then put in our beams and our slabs, right? So let's go to, we want to start from story 1, right? Because what you draw on story 1 will appear below, right? So what we do, we want to start by columns. Just click on columns, then this window will pop up where you can do your settings. You can insert the size of the columns here, you know, and you can also insert the end condition of your column. For this case, I just want my column to be fixed on both ends, right? So after that, you can just come here and be inserting your columns. You can insert them one by one, or you can just select the whole area and your columns will be inserted automatically. You know, the size of the column is 500 by 250 as per the settings here, right? Well, so that is done. About columns, that is done. Then we can move to beams. The same thing will happen. This window will pop up. You can set what you want to happen with the beams, the sizes of the beam, and the end conditions of the beam here. For this case, I just want to use the default, so let me just use 500 by 250. So you can just insert your beams like that, or you can just select the entire area, then your beams will be automatically inserted. That is the beauty of it. Yeah, that is the beauty of it. Maybe let us just view the 3D. For you to view the 3D, just come to the left side here, go to views, right click, and go to 3D physical model. Yeah, very interesting, looking very nice, you know. Yeah, so this is it. Just interesting. We just done our columns and our beams, right? The building is coming up. Well, let us just return to plan. This is what we have. Next thing is to put in our columns. You know, we have to put in our columns. Not our columns, sorry, our slabs. Just go to slabs, and the same thing will happen. A window will come up where you can input your settings, you know, so that once you put them here, everything is set. So what is happening here? We have two tabs. We have the general here, then we have the loads. Come to general. The first thing you select is the end condition of your slab. Well, if you look at, let me just do a quick explanation about that here. If you look at this slab, let me say this panel here, it has two edges discontinuous, right? It is different from this slab because this slab only one edge is discontinuous. This slab, two edges are discontinuous, but for this slab, all the edges are continuous. So when you're choosing which one to use here, you have to really pay attention to that here, because for example, well, we have them 1, 2 up to 12, but then we also have for one way here. So in this case, number 1 is for all edges continuous. So if I select this, that means I need to only put it here because then all the edges are continuous, right? But then let me say number 3. Number 3 is one edge discontinuous, right? So if you come here, one edge here is discontinuous, another edge here is also discontinuous, this one also, this edge is discontinuous. So we can use this slab for these, and also these, right? Yeah, so that is it. You can also change the size of your slab. You can use 175 for this case. This 25 is cover, the concrete cover. You know, you have to put a cover so that your steel is not attacked, you know. So that is it for this. Then you can go to loads. This is where you put in your loads. We have the self weight. You know, once you put in your thickness of slab here, the software will automatically calculate the self weight of that slab, right? Then if there are other loads like the finishes, like partitions, you can now add them here. So I'm going to add an additional load of 4 kilonewtons per square meter to take care of partitions and also the finishes, right? Then I can also put the impost load of maybe 1.5 kilonewtons per square meter. I'm going to ignore roof load for now because we really don't have a roof load here. I'm going to ignore snow load. I'm going to ignore rain load for this case. So that is it. So I want to start with the interior column, which all edges are discontinuous. All edges are continuous. Just click there and your slab is already inserted. Come to the next option, 2 edges discontinuous. 2 edges discontinuous is option number 4. So this one is adjacent edges discontinuous, option number 4. This one here, this one here, this one here, and also this one here. Well, then we go to the last one where one edge is discontinuous, right? So just go to option number 3, then you insert your slab there, slab here, and slab here. Then that is it. That is just it. We've already modeled our first story. You can just go to 3D view and see what really is happening. So interesting, is it? Very interesting, right? This is our building coming up. Very nice. Then from there we can move to other stories. If the stories are different, then you'll have to also model for other stories. You'll also have to draw for other stories. But if they're the same, then you really don't have to draw for other stories. Just copy what is in this story, then you take it to the other stories, right? So to do that, just come to building setting, set out here, then go to stories here, then you just go to the option of generate story, right? Then it will give you an option. Our source story is going to be story number 1. Then you want to take that to the second story and the third story. Just select all of them. Then what do we want to copy? Well, we want to copy columns. We don't have shear walls here. We want to copy beams. We don't have braces. We want to copy slab loads. We want to copy slabs. Well, we don't have ribbed slabs for this case. Then these ones are also not there. Then just say OK. Say yes. Then it's all done. It's all done. We've already copied, right? So this is our building. This is our building. So interesting. So interesting. So we have the slab already with all the loads. We have the final story. We have the second story. We have the first one. So nice. So the next thing after this is analysis. We've already done our analysis. So what we move to next is we go to, we've already done our modeling. We now move to our loading here. We can generate our load combinations, which we are going to use for purposes of this analysis. So just go to loading here. Let me just show you that again. Go to loading, then go to load combinations, load cases and load combinations here. Then you have to check the apply P delta analysis. P delta analysis is where, because of the deflections which will occur in your building, there will be additional moments. You have to really take care of that, because you can't say that your building will not deflect, because in real sense it will deflect, right? So you have to really apply P delta analysis to get those stresses due to that. Then you can just click on generate, loading generator, so that you just generate the loading. So here I just want to leave it as default. What you can see here is define dead load and define live load. We want that, so we just need to keep that as it is. And then define patterns automatically, we leave it as default. And then maybe what we insert is that favorable dead load coefficients, to just give it 1, and favorable dead load coefficient 1.4. This is as per, so all these settings the software has already done as per the code of practice which you selected. Remember, we selected BS8110, so the software has already done that for us here. So the next thing, you just move to horizontal combinations here, and here let's click on the notional loading. Notional loading is where, British standards recommends that because there's some building inaccuracies, we have to take what is called, we have to take the entire weight of that. We take the weight of that story, then we multiply it by a factor, then we apply that load at the flow level, But why? Because there will be those to take care of those construction inconsistencies. You have to apply some lateral load at the flow levels, to take care of that. That is what we call notional loading. So what you do, take weight of that given story, multiply it by, for this case it is 1.5%. That is what the BS code recommends, 1.5%. Multiply it by 1.5%, then that load is what you apply at the flow levels, right? So we've done that. Just say OK, and your load combinations are automatically generated. Then just say OK for that. So we've done our modeling, we've generated our load combinations. Yeah, bit interesting, very interesting, just playing around with the structure, But so the next thing we do is we want to go to well, before we run our analysis, we may want to review so that we ensure that everything is okay. Just come here and do your building model check. Then you want to check all the things, if we have overlapping slabs, overlapping columns, all those. Then start your check. It is telling you that building model check completed, number of errors is equals to 0. That means our building model is on point, So we just say close, because it is okay. We've confirmed that our building model is okay. Well, then we move to next, analysis, right? So in analysis here, we just want to run building analysis. We have different, you can do your flow analysis if you just want to do with your flows. But here, let us just do entire model analysis. So just go to building analysis, this option here, the first option. And then we have this is the window it will bring you to, right? So here we can do some quick settings before we move on. So in building analysis, this is where we can set our materials. We can set our the grids of our materials. Like you can see for columns, the class 2025, shear walls 2025. You can just go with defaults, But if you wanted to change, you can simply go to edit materials here. Then you will have an opportunity to edit your materials. You can edit your class of concrete the way you want. If you want it to be class 30, you can just come there and edit it. But for now, I just want to deal with the default. So just go to project parameters. Here you're going to confirm whether the codes you picked, the codes of practice are the ones which are indicated here. Yeah, we indicated BS8110 for concrete, BS5950 for steel, BS6399 for loading, which is okay. We don't have any problems with that, right? Foundations, allowable stress of soil, you can change your allowable stress of soil. If it is 100, if it is 200, if it is 300. Let us just go with default, right? Then lateral loading, yeah, this is what I was talking about. Apply notional loads at story levels. Lateral load factor is 0.05, which is 1%, 1% of the story, the weight of that story, 1% of it, 1.5% of it, But what is the weight of that story? As the BS recommends, is that the weight of that story is equal to the total dead load of that story, then plus a given percentage of live load. So our total dead load is going to be our total story of that mass is going to be our dead load, which is G, plus our live load, a given percentage of it, because there is no point in time where no point in time where your building will have full live loads, So we just take a percentage of it, because if we design for full live loads, that means it will be very uneconomic design, because in the entire lifetime of that building, chances are high that it will not achieve the full live loads, right? So after that, you just say, you can say okay, but before you say okay, let us see what is here. Do you want to consider your columns as braced or unbraced? For this case, they're unbraced because you don't have a shear wall to take care of the lateral loads, so they're unbraced. They're also, in both directions, direction 1, direction 2, they're all unbraced. Then you can go to, you can set your project title. Just say finite element methods. I'm on watch, so I can just say made by all watch. Made by all watch here. Maybe let me just say checked by watch again for this case. Project number maybe 222. Project date maybe 08. Like that. Then I say okay. So we've already set our project parameters here. Loading combinations, the ones we already set, so we just leave them as that. Then you go to wind and story loading. I'm not intending to add wind for now, because that will take a bit of time, so I will just do that for another video. Then after pre-analysis settings, you can go to model options. Model options, this is where we can choose what we want to do with our project, So we have the first option, model here. Beam sections, we want to analyze them as rectangular, not as flange. But there's a difference between flange section and also rectangular sections, right? You can explore more about that. Just go to shear wall here. You can do a little settings here. We want to include them in finite element shell model, but remember we don't have shear walls here. That's why it's not even necessary to do the settings there, because we don't have shear walls here. For our slab model, slabs to define rigid diaphragm. Rigid diaphragm means that slabs are meant to transfer the lateral loads to the resisting systems, But we want ours to be taken by the frame, so we just say no rigid diaphragm for floor levels, right? And then this is the interesting part. Include slab in building model. Just say okay, because we want to analyze our slabs together with the model there. And then stories to be meshed. Want to mesh all the stories. So that just check all this so that we mesh all the stories. Then what is the size of our elements? Shell element size. This is what I was explaining the other day, that the smaller the size of your elements, the more accurate the results. But then the smaller the size of your element, the longer the time it takes to do this analysis, right? So you can even decide to make your element 1 millimeter by 1 millimeter, but that may take forever to analyze, which is not really appropriate, So for this case, I'm setting mine to 1 meter by 1 meter, an element of 1 meter by 1 meter, so that we get a result very quickly. So just leave your element to be 1 meter, the minimum 1 meter, maximum also 1 meter, and that is it. These ones are really not necessary for now. Then just go to analysis, then you go to building analysis. You can also decide to perform agent value analysis, but not necessary. You can just leave that for now. Just do building analysis for now. Do you want to design? Well, if you want to design, we check all this, but for now we are really interested with the analysis part. So just go to building analysis. It's doing the analysis, very interesting, so just give it some time. It's doing the analysis. You can see creating finite element mesh. It's a bit interesting, so let us just give it some time. The software is running the analysis. Yeah, so our analysis is done, and this is what the software is saying. Relative story drift satisfy the limits, that's okay, and also in the direction too, it satisfies the limit. So our analysis is okay. You can just close this, and it will take us to analytical model. Perfect. We are already there in the analytical model. This is where the software has brought us. So if you give it a keen look, you'll see this is the analytical model. Very interesting, These are our meshes. This is the mesh, for the slabs. These are the meshes, You can just rotate it around, looking very nice. Well, so we want to see our results, how things really are. So we can just start from displacements. If you want to look at the displacements, you can see how big the displacements are. You can just give it a keen look and see. You see your slabs are deflecting seriously. But the maximum deflection you're given here to be 0.00944. Very minimal. Yeah. So you can just turn on the animation so that you have a look at how it is behaving. That is how your slab will be deflecting. Yeah. Yeah. Yeah, you can just turn off the animation. We've seen the slabs, the deflections. We can also check the you can check the values. You can obviously check the values for deflection. It's just too much. So you can see the deflection at every node. That is in the x direction. The x direction, we don't really expect it to deflect that much, So we have deflection at every node because This is what finite element analysis is doing. It breaks this down, then it calculates deflection, calculates stresses at every node. So we have deflections at this node here, you know. Yeah, deflections at nodes. You can just look around. In the y direction, the deflections in the y direction, you don't expect them to be much. In the y direction, these are the deflections. You can also check deflections in the z direction. This is what we expect to be a bit more. You know, you see we have the z direction, the upward direction here. So these are the deflections in our slab. So you can actually take the maximum deflection here is what you use for purposes of design. You can see the maximum deflection is 9 millimeters. You know, 9 millimeters. So that is it. Very interesting. Yeah, you can always check also we want to check you can just turn off deflection. We want to check the diagrams. We have this is the axial load diagrams. This one is for purposes of let me just turn off the beams. We have only the axial loads in the columns here. You can see the upper columns carries little load. From what we have here, the upper columns carries very little loads, right? Then the columns in the second story here carries a bit more loads. Then the columns in the story below carries very high loads. That is why the columns, the upper columns, does not need to be as strong as the lower columns, because the lower columns carries the cumulative weight from top going down. You know? Yeah, so that is it. You can see how your columns will behave. That is the axial loads in your columns. You can just turn that off. Now we can check on the moment diagrams. So this is the moment diagrams for your columns. This is how your columns will behave. So these are the moments you can take for purposes of design. For the inner columns, the moments are so negligible because the beams are kind of, the spacing of the beams are of equal span. So the moments, they're balancing out. So there are no so much moments in the interior columns, but the outer columns have great moments, right? So you just have to check that and be keen about it. Very interesting. Yeah, you can also check the bending moment for the beams. You can just turn on that here, bending moment and 3 when you turn on for the beams. So you see for the first story, let us see. See moments in this beam. For example, the mid-span moments 11.2, 7.29, 3.85. You know. So from here you can do the analysis. Then you use those forces to do your designs. Well, from there we can as well check the. We can actually also check the contours so that you see how the stresses are distributed. This is our slab. So just go to contours here, then check on the contours. Then here you can check the contours for moments, for deflections, and so forth. So if we check contours for deflections, let me just turn that on. It's a bit heavy. Let us just give it time. It is already here, so it's indicating that it is indicating that our maximum deflection in the z direction is areas with the blue, the blue colors. You can see that here, and the maximum deflection is 9 millimeters. So these areas, these are the interior points of our slabs. So these are where we have maximum deflections. I do know the maximum deflection for that case is 0.0009 meters. So you can take, for example, this element here. You can just take, it's a bit heavy, so it's taking. So we just select that element, then we show details of that element. Then you can see the deflection at that point, that element. You can see the deflection at this point in this element, deflection at this point in this element, right? That is it. Very interesting. You can also take another element. Maybe we take another element in this other slab. We take this element, then we show detailed diagram. Let us see what is happening with this element. For this element, the deflection at this node is 2 millimeters, 1.8, and 3 millimeters. Yeah. So from here you can see your deflections, and you can see what you are really designing for, and you can always change it. You know, these deflections are dependent on the different load combinations. If you select live load 1.4 live load plus 1.6 dead load, 1.4 dead load plus 1.6 dead load, it will give you different values, right? It's taking a bit of time because of those contours. Maybe I just tap the contours so that it doesn't become very heavy. Yeah, so if we turn on for the first load combination, that is dead load 1.4 dead load plus 1.6 live load, then our maximum deflection is 15.6 millimeters. Then it is points with this blue color. So just come to blue color, areas having blue colors here, these areas here, these are the areas which are having maximum deflection. So as a designer, you know where to put a lot of reinforcement, or where to increase the depth of your slab. You can check that for different load combinations. Yeah. So I think that is it. I just wanted to show us that, so that we appreciate the importance of finite element analysis. I think this one is really good enough for now. If there is any questions, I'd really love to interact with us. Just post in the comment section so that I will respond to it. Otherwise, I really request to stop here. I think I've shown just everything we needed to know. Yeah, just everything we really required to know. So that is it. I've just as a summary, I've shown from modeling to how you can apply your loads, then to how you can run your analysis, then to how you can interpret. We have the color codes here, different color codes, which will tell you points of different stresses. High stress is indicated by blue color here, followed by the cyan, and so forth and so forth. So that is how you can interpret the results here, which can help you as a designer to make a very good decision. Otherwise, I really tend to stop here. Post questions. If this video is helpful to you, please subscribe. Please also like the video, so that you also motivate me. It becomes a win-win situation, right? Otherwise, thank you so much, and make sure you stay safe wherever you are. Bye.